second Public Solutions Forum webinar on clean energy and climate finance. Today we will be discussing corporate partnerships as a model for financing carbon capture technology. We're excited by the significant number of attendees for today's webinar. We had over 200 people register, so we know there's a lot of interest in the topic. I also want to thank our panelists, David Brown, Bill Brown, and Walker Dimmig, for taking time out of their busy schedules to participate in our webinar. I think it's going to be a great discussion, and let's take a look at our agenda. So we'll start with a brief intro to C2ES. I'll introduce our panelists. Then I'll set the stage for our conversation by describing the climate benefits of carbon capture technology. David Brown will provide an overview of Exelon's portfolio approach to investing in innovative clean energy technologies. Bill Brown and Walker Dimmig will explain the benefits of this partnership from the perspective of 8 Rivers Capital and Net Power. They will also describe the alum cycle and what makes this approach to carbon capture technology so unique. These presentations will be followed by an interactive discussion, and we will open the conversation to audience questions. So before we get started, let's go over a few housekeeping issues. The webinar is being recorded, and we'll post the slides on our website next week. Webinar attendees are muted. You can submit your questions online through the chat box, and I'll raise them for our panelists. If you have clarifying questions, I can raise them during the moderated discussion, but of course, at the end, we'll definitely have time to take audience questions on any aspects of financing carbon capture. So with that, let me begin by saying a few words about C2ES. We're an independent, nonpartisan, not-for-profit organization founded 18 years ago as the Pew Center on Global Climate Change. Our core mission is to advance practical solutions to reduce greenhouse gas emissions, deploy clean energy, and build resilience to a changing climate. We pursue our mission through a number of activities, such as conducting research and analysis on topics like climate resilience, finance, technology solutions, and policy options. We have many publications, all of which are freely available on our website. We have a Business Environmental Leadership Council. It is made up of 30 companies, including Exelon. Most of these companies are Fortune 100 companies, and they represent the multi-sector nature of the U.S. economy. As you can see on the slide, we have companies from the banking and finance sector, automobiles, extractives, manufacturing, technology, utilities, and others. This conversation is part of a long-running effort at C2ES called the Solutions Forum, and it brings together business leaders as well as states and city officials to find pragmatic solutions to some of our country's biggest climate and energy challenges. We started the Solutions Forum with a series of public discussions in DC on the topics of market-based strategies, energy efficiency, and clean energy finance. In the last year, we've held a series of invitation-only workshops across the country and webinars to explore key issues like market-based strategies and climate resilience in depth. We're happy to be bringing this webinar to you today. We have some great speakers, and we'd like to thank our sponsors for making this event possible. And these include the Bloomberg Philanthropies Group, Energy Foundation, and the JPB Foundation. Now I'd like to give a few short introductions, and you can find the detailed bios of the speakers on our website, as you can see here. David Brown is the Senior Vice President for Federal Government Affairs and Public Policy at Exelon. He is Exelon's primary liaison with Congress and federal agencies. Exelon, of course, is a family of companies, including 6 utilities that deliver electricity and natural gas in Delaware, DC, Illinois, Maryland, New Jersey, and Pennsylvania. Bill Brown is the CEO of Net Power and the co-founder and CEO of 8 Rivers Capital. 8 Rivers focuses on financing and commercializing technologies related to water, energy, telecom, and space launch. Net Power is focused on commercializing the technology we'll talk about today, which produces electricity from fossil fuels while capturing emissions. Walker Dimmig is a principal at 8 Rivers Capital, a company that invents and commercializes breakthrough industrial technologies. He has helped lead Net Power's commercialization through raising $140 million and building partnerships with Exelon, Toshiba, and CB&I. So to set the stage for our conversation today, I just wanted to make 3 points about carbon capture technology. First, carbon capture is an essential technology. More than half of the models in the IPCC fifth assessment fail to limit warming to 2 degrees Celsius of pre-industrial levels without carbon capture. For those models that could stay within 2 degrees, the mitigation cost rose 138%. Additionally, the IEA concluded that carbon capture could provide 13% of cumulative emissions reductions needed by 2050, and that's the wedge you see here in dark blue. The second point I want to make is that carbon capture is a solution for both the power sector and the industrial sector. So in the power sector, carbon capture can significantly reduce emissions from coal and gas-fired power plants. In the industrial sector, carbon capture is the only practical way to achieve deep decarbonization of facilities that make steel, cement, fertilizer, chemicals, as well as refineries. In these industries, CO2 is often a byproduct of the process to make these materials. That's why capturing those emissions is so critical. The U.S. industrial sector is responsible for 21% of our greenhouse gas emissions and 18% of our CO2 emissions. Additionally, carbon capture can be used with biomass, which could one day enable negative emissions. One of our first steps in that direction is the use of carbon capture on ethanol. The third and final point I want to make is that there's a lot of exciting work happening right now into options to reuse CO2. So the Global CO2 Initiative is looking to capture 10% of annual global CO2 emissions and transform them into valuable products. Here are the types of categories that researchers are looking into. So you can see construction materials, polymers, fuel, chemical, agricultural. The Global CO2 Initiative recently issued a roadmap identifying the top 5 product categories, and those are concrete, fuels, including methane and liquid fuels, carbonate aggregates, which falls under construction materials, polymers, and methanol. So this is a really important space to watch. And with those 3 points as context, I'd like to turn it over to David to talk about Exelon's portfolio approach to investing in a suite of clean energy solutions.
Great, thanks, and thank you for the opportunity to participate in today's session. Let me start by giving you all a quick overview of Exelon. On the next slide, you can see just a snapshot of who we are corporately. We are the largest utility in the United States in terms of customers, with over 10 million customers at the 6 utilities you cited. We're also the largest generator of clean energy in the United States, primarily nuclear, but also hydro, wind, solar, and other renewables. We're also the largest retail provider of competitive electricity in the United States. Exelon's been a leader in climate advocacy since our founding in 2000. We've been recognized by the Dow Jones Sustainability Index, EPA's Energy Star program, and others for our efforts on climate and sustainability. And as I noted, we're the largest generator of clean energy in the U.S. Over 92% of our portfolio is carbon-free. If you look at the next slide, it gives you an overview of our generation company and the resources that we have. We also undertook several years ago an ambitious program we called Exelon 2020 that resulted in the reduction, displacement, or offset of our entire carbon emissions footprint. We actually achieved that goal 7 years early in 2013. As part of that effort, we dramatically reduced our power plant emissions. We reduced our energy use by 25% or more at each of our facilities, and we increased dramatically our use of alternative fuel vehicles at our fleet around the country. We're also working on helping our customers reduce their emissions and energy use. Our 6 utilities have aggressive energy efficiency programs that range from smart meter deployment to the distribution of millions of energy efficient light bulbs, bounties on the so-called beer fridge, and programs to integrate distributed generation into our systems. If you look at the next slide, our Constellation Energy company serves 2/3 of the Fortune 100 companies, as well as the federal government, and provides retail electric and gas products as well as distributed generation and energy management services. Overall, Constellation has partnerships for 275 megawatts of solar and 165 megawatts of distributed generation for those customers that I mentioned. And then finally, we're looking over the horizon with an eye to the future. Our Constellation Technology Ventures Group engages at very early stages in energy-related startups. Their current portfolio includes companies involved in batteries, fuel cells, electric vehicles, electric buses, energy management, and smart lighting. But we also realize that our nuclear plants are not going to be around forever, and we're constantly on the lookout for technologies that promise to provide clean, affordable, and reliable power supplies. And our partnership with Net Power is a byproduct of that focus. We're excited to be a partner with 8 Rivers Capital and CB&I in this effort, and I'll let Walker and Bill talk more about the technology and the plant specifics, but for our part, we view this as a very promising technology that can play a key role in ensuring that we keep the lights on with a reliable supply of clean energy into the future. Thanks.
Okay, thanks, David. And now I'll turn it over to Walker to talk about the perspective from 8 Rivers Capital.
Thanks, Fatima, and thank you, David, for that introduction to Exelon. I'm going to talk to you a little bit today very briefly about 8 Rivers Capital, and sort of the other side of the equation from a large company like Exelon. We're going to look at sort of how a smaller technology development firm looks at commercializing larger scale technologies, and then Bill will dive into the specific sort of case study of Net Power and how what that technology looks like and how we approach commercializing it. Next. So a little bit about who we are. 8 Rivers, our mission is to build the sustainable infrastructure of tomorrow. We have a view that, in general, we think sort of for infrastructure scale technologies, they aren't being developed with the same level of kind of speed, aggressiveness, and for lack of a better word, disruptiveness as you see in other sectors, particularly in biotech sectors. Variety of reasons for that. Some are structural, sort of for the industries like clean tech, like energy, that have some structural reasons. But we think also, that there are reasons related to sort of the model with which those technologies are pursued in certain spaces. So, for instance, the VC community, which supports a lot of these other kind of very fast-moving innovations, hasn't really worked well in clean tech. There are reasons for that, from financing requirements to timeline for development. We also think that if you look at the corporate space, they've also they have their own internal struggles with innovation that are sort of inherent structural issues. Lots of innovators dilemma type problems. So our model is to take a different approach to pursuing infrastructure scale technologies. Sort of take that smaller company, disruptive, innovative, fast moving approach, and successfully get technologies out into the commercial space. We use 3 filters to look at technologies. The first 2 are really quite standard, kind of not all that exciting. You'll see them everywhere. We just call them cheaper and better. Those are your standard kind of disruptive technology filters, saying they have to have some sort of cost advantage, and then they have to have some other superior functionality. So in the case of Net Power, it's going to be that not only does it have a cost advantage, but it's cleaner. The sort of big thing that we do differently is our third filter, big. We talk about what we call the 3 comma rule. 3 commas is in $1 billion in revenue within 5 to 10 years. Now, we understand there's plenty of sort of execution risk, technology risk, all sorts of reasons that might not ultimately be successful, but we want to look for technologies that have the potential to be billion-dollar technologies, because we think those help us in our execution. And that's because what we like to do is engage strategic partners, large corporate strategic partners, early on in the process of development. And in order to get sort of the focus we need out of those partners, in order to get the resources we need out of them, we have to have opportunities that they view to be big enough to warrant their attention and their resources. And when we say resources, we're looking for more than just the financial resources of a large company like Exelon or CB&I or Toshiba, who we work with on net power. We view them as having a huge amount of intellectual resource. So that's everything from IP to know-how to processes, human capital. They have a lot of people already in place, teams that operate well together that know how to execute on technology. So next. Good way to look at sort of how we view those corporate partnerships is sort of in how you staff these things. So this is kind of how the 8 Rivers kind of partnership process plays out. You'll see at the beginning of this chart, the first 3 layers there, the blue, the green, are sort of 8 Rivers is kind of innovation and development teams, our engineering, our business teams, and at the beginning we're pretty much everything that's there. But what we've recognized is that as you move an innovative technology down the path for a firm like ours, it becomes more about executing. And there are folks in the spaces where we're operating who actually have all the expertise in place to execute successfully. And so what we like to do is find, what are the resources we need to execute, and how do we bring those people into the fold so that we continue to do what we're good at, which is focus on innovating and keeping technology sort of excellent, while we have partners that come in and help us then do the things that they're very good at, whether it's building a plant or building a turbine or whatever it may be, rather than try to staff up internally like a traditional VC company might do. We look to bring those people in who already know how to do that and already have the structures in place. So next, so to look at sort of how this works for the net power case study, which Bill will dive into with much greater detail. If you think about our structure, so we have 8 Rivers, Exelon, CB&I, and Toshiba involved in this project. So 8 Rivers, we were the inventor of the technology. We kind of have this engineering oversight to make sure the core focus of the technology isn't lost, that its excellence isn't lost, that it doesn't lose its competitive edge, and that we continue to push it sort of down the path. It doesn't just remain static. We've got a partnership with Exelon in here because they bring both a customer perspective. So are we developing a technology that they need, that they want, that they'll deploy? And they also can provide a huge amount of expertise in terms of developing assets. They develop, own, and operate power plants all over the country. So whether it was siting or permitting for a demonstration plant, whether it's on-site construction oversight that they're currently engaged in, or whether it'll be future O&M activities, they bring that to the table, and we don't have to take that risk, that execution risk, on doing it for the first time. CB&I obviously is bringing engineering, procurement, and construction expertise, and Toshiba is developing a new turbine, and they particularly had expertise in high-pressure turbines that we knew we would need. In addition to the human capital resources, they have large financial resources. So there's $140 million in cash and in-kind resources invested into this facility. That would have been a lot for sort of a traditional kind of venture community to fund. And also Toshiba is doing a lot of in-kind turbine development. Not only are all these folks involved, bring these resources to the table, but we've involved them in a way that we've incentivized long-term success of the technology. So it's not just, we know we need to build the plant, so let's hire an EPC firm to go build the demonstration plant, but we're focused only on that project, but let's focus on what the construction and the design and construction of these plants look like out into the future. And let's not just worry about maximizing profits on a single project, but let's understand the vision is to have this technology widely deployed and for everyone to benefit from it. So we think we've set up a structure that incentivizes that for all the folks involved. And with that, I think I'll turn it over to Bill to discuss net power in particular.
Thank you, Walker, and David Brown. Thank you also. As Walker indicated, it is the excellence that Exelon has brought to the table, as well as CB&I, that have really helped us do this. And Toshiba also brings the turbine along. The Exelon story is very important for us. When we were focusing on for instance, designing our control system, within a week, we had control system experts from all around the Exelon system show up in Durham to to help us get started on control design. When we focused on plant operation or construction, people from all throughout the Exelon system showed up. And so it's wonderful to have a virtual workforce that can be called on a just-in-time basis without having to go out and find people. You already have the benefits of a company that has acquired talent, the best talent in the business, and we have benefited from that in both the excellence and execution as well as the speed. So right there in the front of this slide, you see an artist rendering of the plant that we're building down in Houston. We also, you'll see on the left though, C2ES, and that's finally I want to thank C2ES. Fatima, your organization provides a very, very important service to the community. You know, way back, for instance, when Silicon Valley was first being formed, the reason Silicon Valley came together is because there were various people in Silicon Valley who acted as important conveners, who brought together industry, academia, and the government. And that is something that C2ES does with superb expertise. And we're very fortunate to have C2ES in the system convening people and with a focus towards cheap, clean energy, as well as a number of other solutions for the energy and the environment, for the economy and the environment. On the next slide, you will see net power in a nutshell. We make electricity from natural gas. We cost the same as or less than electricity from existing natural gas power plants. We will capture substantially all the carbon and non-carbon atmospheric emissions without any additional costs. And we also don't need to use water at a small reduction in efficiency. So that's what we do. And we'll talk about that a little more later. So on the next slide, you'll see, in the next one, we'll look at the technology. These are the basic pieces of equipment in our cycle. It's pretty simple. It's not an IGCC plant. At the very core of this plant is a simple cycle gas turbine. That's the turbine that Toshiba made and has actually shipped to our facility down in La Porte, Texas, outside of Houston. The balance of the plant, normally in a combined cycle plant, is the simple cycle gas turbine normally dumps into a steam cycle, a heat recovery steam generator. The problem with every single steam cycle out there is because of the nature of water itself, the amount of heat that has to be rejected into the atmosphere is massive. And that heat is forever lost. And that is an intrinsic problem in every steam cycle out there. So we looked at a combined cycle plant and we said, well, we need to do something other than using the steam. And instead what we did was we said if we can keep that heat in the system rather than rejecting it, we can use that extra energy that's otherwise sent up into the atmosphere and use it to fund the parasitic energy of an air separation unit for oxy-combustion, as well as a compressor and pump for recompression, and basically drive this thing like a heat pump. So we're basically a heat pump cycle. If you look at the next page, the lines, the width of these lines on the next page are proportional to the mass. And you can see in the front of our turbine comes 94% of the mass that comes into the front of our turbine is hot carbon dioxide. It's 720 degrees C. That means that oxygen and natural gas, those two little lines that you see at the top, we don't need as much O2 and CH4 to come in to heat that gas up from 720 degrees C up to 1150. So at the very core, you've got 6% new mass coming in, heating up the big carbon dioxide heat pump. And that 6% mass leaves at the lower right-hand corner. It's pipeline ready and pipeline pressure carbon dioxide and clean water. Now the next slide, two more slides, let's talk about Net Power's basic value proposition. Selling only electricity. Only electricity, we have the same pure economics as traditional power plants. And when I say pure economics, I mean no support from government, no carbon tax, no nothing. We are the same pure economics as traditional power plants, and yet we capture all the CO2 and other atmospheric emissions. The bottom line, this means the world can meet all of its climate targets and even more without having to pay more for electricity. In the next slide, we'll sort of look at this. The next slide, we start with that curve at the bottom comes from an article that was done by Steve Brick and Sam Thernstrom. Many of you know them, I'm sure. In fact, they might even be on the line here. We took 3 data points from them from that article. They did a system-wide analysis of California, Wisconsin, and Germany, and looked at natural gas combined cycle. They looked at renewables, and they figured out how do you put the energy system together. 100% natural gas combined cycle comes out to a cost of electricity roughly of $60 per megawatt hour, but it emits all this CO2. There's no CO2 reduction from a combined cycle plant. Sure, there's less CO2, but there's no CO2 abatement. If you then go the step of going to targeting 50% CO2 reduction, your electricity price doubles. You've got half renewables, half combined cycle. And then you can go for 85% reduction, you go way far out to the right. You hit a lot of diminishing returns on this. And while you have 173% renewables buildup, you have spinning reserves of 15% whether it's combined cycle or simple cycle power plants. That's the world that exists. Out there in that far right with 85% abatement, the cost of electricity is 7 times what it is with just a plain old combined cycle. If you go up on that chart and you look, Net Power can achieve the same cost as a combined cycle, but 100% carbon abatement. Then Net Power will not be usable everywhere. There will be various reasons why you will want to use renewables. And while in putting the two of these together, Net Power and renewables make a really strong partnership for addressing the world's climate problems without having to pay more for electricity. Moving on now. We've got, on the next slide, Net Power also has an enhanced value proposition. As we've said earlier, no water is needed. We can also burn inexpensive fuels. Remember that big orange arrow of recycled CO2 and that little tiny arrow of methane? Well, actually, that little tiny arrow of methane mixed with a little equal sliver of CO2 is unprocessed gas. It's called acid gas. It's natural gas mixed with CO2. We can burn acid gas without thinking hard at all. We can also burn sour gas and associated gas and produced gas and flare gas. We can burn these things that people otherwise wanted to flare. And as we look at this line here, we will address some of the spillage of methane that has been problematic for our world, because we can turn all that extra stuff into something that is usable in the form of electricity. We capture all the CO2. We capture it at no extra cost. It's at pipeline quality and pressure. And we produce industrial gases. Big ones are nitrogen and argon, but with an adjustment of our system, we can also produce syngas. So on the next page, you'll see the big gases, the CO2, the nitrogen, the argon, and the amounts at the very bottom that a single net power 300 megawatt electric power plant will produce. And note that of that, if that CO2 were used for enhanced oil recovery, that would result in an annual production of 1.2 to 1.6 million barrels of oil a year. Now, next page. The size of EOR is substantial. It's already big business in the U.S. And if you this shows you the dot sizes, show you the size of the business for the big CO2 EOR projects in the U.S. And as a guide, the size of the oxy bubble on the right, that is the output of 45 net power turbines. Next page. Globally, net power CO2 will change the entire oil stack because there's not just an EOR business in the United States, there's also an EOR business throughout the world. And if you look at the blue line, that's the existing oil stack in the world. Onshore Middle East, offshore shelf, deep water, Russia, rest of the world, ultra deep, North America shale, and so on. And if you look far right, up there at the far right, that would be CO2 enhanced oil recovery with traditional CCS. That's post-combustion carbon capture. It requires, right now in the U.S., it requires $75 oil in the United States for post-combustion carbon capture to be economic. Now, there's a range, but if you look at the gray-green line below, you can see with the net power process, we add on a whole new level to the global oil stack. And we won't be able to produce as much oil as onshore Middle East, but we will produce a substantial amount of oil, and we will be able to be cost competitive with onshore Middle East. And moreover, we will backfill that oil with carbon dioxide that's captured. Next slide. Just to measure this out, we just put took 4 different data points and just put them on a slide for different regions of the world. These are the number of net power plants needed to satisfy the different markets. First column is the power demand to 2025 from the IEA. This is both this is replacement fossil plants as well as new fossil plants. Then we look at the numbers going out to 2040. Then we looked at EOR demand from that one article that's mentioned there. Then we looked at enhanced coal bed methane recovery demand in that article mentioned there. And you can see in Canada, the U.S., there's more than enough EOR demand to suck up the CO2 from the net power plants that are projected by IEA. Europe, there isn't. Europe, it's a push. Asia, there's not enough EOR. Russia, there is enough EOR. Middle East, there's enough. In South America, there's enough. But those places where there isn't enough enhanced oil recovery demand, there's an enhanced coal bed methane recovery demand. Next slide. Here we are in La Porte, Texas. We're actually farther along than this at this point, but this plant will be a 50 megawatt thermal plant. It will be commissioned and on track for startup in 2017. Next slide. So the current uptake. On commercial plants, we're in active discussions with 5 different entities for serial number 1. Some are in the oil patch, some are our power producers, and putting those together, those 2 halves together is part of what engages us right now. We're doing site selection with many people. We're in C-suite discussions with 11 out of 15 top North American power producers, and in C-suite discussions with 5 major oil and gas companies. In the La Porte facility, while we expect testing to be completed in 2017, we have to look beyond 2017. And so several firms are with interest in carbon dioxide and supercritical CO2 have expressed interest in scheduling use of that facility. And if there are people here on this call who are interested in testing their equipment and with our facility, we can achieve temperatures and pressures that will allow any sort of technology that people can dream of to be tested. So that is, next slide. To be very clear in terms of if we had the turbines today, if Toshiba had the full-scale turbines ready to go, I could place 20 of those turbines immediately and find homes for 30 more turbines in about a year. so the demand for this is very palpable. And then the next slide, I want to close with this. One senior DOE official said to us about Net Power that Net Power does not make natural gas a bridge or a pier. It makes it a destination. So that's it.
Thank you. That was great. We have a couple questions that came in through the question portal, so I just wanted to raise them for you. The first question is, what kind of NOx emission rates are these sites operating with or without controls?
Walker, why don't you go into that?
Was that yeah, sure. Was it the NOx emissions at these plants? I didn't quite hear you, Fatima, sorry.
Oh, sure. Sorry, yes. The question was, what sort of NOx emission rates do these sites operate with or without controls?
So since we are an oxy-combustion process, that means we're bringing in pure oxygen rather than ambient air into the front of the system. And so you're not bringing nitrogen in. So you form almost no NOx. There'll be a little nitrogen coming in through that exists in the fuel itself, the natural gas. But from an emission standpoint, even if we were to say vent our emissions, our CO2 emission stream, within that stream there would be virtually no NOx. I think when we've looked at it, it's your car in a short period of time would emit more NOx than one of these plants in a year. And so that's actually a huge benefit for siting these plants. You know, if most urban areas in the U.S. are EPA non-attainment zones for ozone, which would require you to get a NOx offset if you're looking to build there. So obviously, not emitting any NOx enables us to site these plants in areas that otherwise are very difficult for conventional technologies.
Thank you. That's great. Another question was, what size do you consider to be commercial scale size?
So our commercial, go ahead, Bill.
Our commercial size, I sort of feel like on this particular one at the moment, like Henry Ford, you can have any size you want as long as it's 300 megawatt electric. That's the first turbine we're building, and to be clear, the turbine, the turbine in LaPorte, Texas, is a 50 megawatt thermal turbine. It's actually a 200 megawatt thermal turbine, and so that means that we just essentially pulled 6 spark plugs out of a V8 engine, and we're just running it on 2 spark plugs. That allows us to make sure that the balance of plant in Texas is small. However, the turbine that's being tested is 200 megawatt thermal. Then when our full-scale turbine is 500 megawatt thermal, roughly 300 megawatt electric to the grid. And that's net of all parasitic loads for ASU and compression and stuff like that. So net, we're 59, 60% efficient, and that's the size of turbine that we're putting out to begin with. Now we can scale up, later on. I mean, we're sort of more like an F.04 frame in terms of comparability. We do have on the drawing board the ability to go up to H-frame sizes, and we also have it on the drawing board the potential to go smaller. But right now, we feel that the best point to get to in the market are these 300 megawatt plants.
Okay, great. And I wanted to have a bit of a discussion. I'm just going to advance through these appendix slides real quick to talk about some of the issues that come up with financing carbon capture and different approaches to it. So I'll start with the first question, which is, what do you see as the comparative advantages of corporate partnerships focused on RD&D and carbon capture as compared to venture capital and other sources of investment? And I'll open that up to whether it's David or Bill or Walker, whoever would like to start.
I'll start with that. Go ahead, David. Yep.
Yeah, I'll just give you a quick perspective from our sector, and that is that, we've got, as I mentioned, this technology ventures group within Constellation, and we're really getting engaged when companies are really at their infancy. So they benefit from both capital and the expertise that we bring in, but we're primarily making it as an investment without necessarily planning to deploy the technology itself. Here, we've got a much more mature technology. They're also benefiting from capital and from the expertise we bring, but we view this as both an investment opportunity, but also as a technology that we think is ready for us to deploy when the time comes as well.
And following on that, that is so important. If you remember back to that chart that Walker put up with the personnel, the total number of personnel at the various stages, when we started out coming up with our quote idea, the kernel idea for the alum cycle, and at that point we were actually thinking about starting with coal. And as we went out to the world, we started learning a number of things. We learned that the market for coal was not there, or at least in the United States, that the interest was in natural gas, that the interest was in enhanced oil recovery, and it was Exelon's input when we were first having our conversations with Exelon and with other potential partners that helped us figure out what the market should be. And normally, too many startup firms don't have market definition as a critical part of their first stage. They should, but by reaching out to the customers to begin with, we were able to get a very, very good focus on the market. And then that leads us to the next phase that allows us to go out and do the prototyping. Well, once we're starting to do the prototyping, the 8 Rivers team is all about inventing things, and a normal VC model would have 8 Rivers going out and hiring a bunch of people to building a team. And as most people know, team is one of the biggest risks of execution. If you don't hire the right team and don't pull it together and making that team congeal, you have massive execution risk. Well, with Exelon, they've already built the teams. And in fact, they rotate the different teams in on an as-needed basis. And so I think that we have a much bigger claim to assets by partnering with someone like Exelon and CB&I and Toshiba. So it's the team building phase, it's the market definition, it's the execution. And part of this also comes from the way that Silicon Valley has changed. Before the dot-com era, VC firms actually were in the business of providing domain expertise. But as the size of investments got smaller in the VC world, and as the number of investments increased, the traditional role of VC of providing sort of hands-on domain expertise waned, and that's what we see from corporate partnerships that we have with Exelon, Toshiba, and CB&I.
Thank you. That's a great discussion of some of the advantages. Would you mind talking a little bit about some of the challenges that are unique to corporate partnerships focused on RD&D?
Well, we recognize that there would be a possibility with corporation to think of us as just an extension of the corporation. And so we had to work really hard to create the right balance of involvement and independence. And that took people from 8 Rivers and Exelon and CB&I and Toshiba figuring out how to dance together. And anytime that you put something together like this, coordination problems among giants can be a challenge. But we are very fortunate that with each one of these partners, that the CEO at each one of these partners is very much of a believer in this technology, and the CEO can make sure that the balances get drawn properly. But that is a potential challenge, but we happen to avoid that by just learning to dance together.
That's great. Does anyone else want to comment on that? Okay. If
this is Walker. I would just.
Yeah,
oh, go ahead. I was going to say, I think, yeah, it's very important that you know, when you're working with a larger corporation, you've got to make sure, you know, not everyone that comes in at any given time is you know, has the experience with the technology or knows where it's going, or you know, if you're bringing a team in, say from Exelon to help with O&M, well, they might not have been part of the process the whole time. So I also think it's always important. One thing we've had to focus on is ensuring, as we bring in new resources from our partners, that they sort of understand the larger goal and larger vision, and can get excited and get on board about that, on board with that, and that gives sort of more buy-in, you know, amongst the sort of the team members. So.
yeah, that's a really good point. So if there are, you know, folks on the call here who would be interested in this, what kind of advice would you give to corporate R&D offices that are interested in investing in clean tech, including exploring these types of corporate partnerships?
This is David. I guess from our perspective, it all starts with relationships and getting out there and meeting with folks and really learning about what opportunities are out there. I think that our Tech Ventures folks meet with dozens of folks a month, and I know that this partnership really arose because of the existing work that Rivers Capital and CB&I were doing together on this project. And CB&I and Exelon have a very long relationship dating back to the days when they were Shaw, because of the work that they do at our nuclear units. So I think you know, just getting out there and meeting with as many people as possible is really critical. That way you identify the opportunities that might be of interest.
I agree with David. In fact, I think the key to as David pointed out, our success was actually forging the relationship with the traditional business units first. And I know that there are a number of corporate VCs that this will terrify, but if the BUs are really interested in this, they help drive it. And so for the corporate VCs out there, I would just really encourage them to make sure that they get their BUs engaged early, as long as it's the right size. And that goes back to our 3 comma rule, as in $1 billion. You don't want to get the BUs involved if you don't think that this can be a material thing for them, and if you're just doing this for an investment. But if you do think that something's large enough that it can be material, engaging the business units will yield huge amounts of results.
Okay, great. So shifting gears a little bit, we know that Mission Innovation is an initiative that was launched at COP21 to dramatically accelerate public and private clean energy innovation. So through the initiative, 20 countries are committing to double their clean energy R&D investment over 5 years. And these countries include China, India, the United States, Indonesia, and Brazil. Mission Innovation is complemented by a separate private sector-led effort that's pledged to invest private capital in clean energy, focusing on early-stage innovations. So this parallel initiative is called the Breakthrough Energy Coalition, and it's spearheaded by Bill Gates. It's a coalition of over 28 significant private capital investors from 10 countries. In light of Mission Innovation and the Breakthrough Energy Coalition, what do you think is the right relationship between the public and private sectors to mobilize investment in clean energy, including carbon capture?
This is Walker. I can start that one off. So I think there are 2 points I want to make here. I mean, I think I do think it's essential to have the private sector involved, even from the start, in terms of engaging with the public sector on R&D. I mean, I think it's also important that there's engagement not just at the technical level, but at the business level. I think that's one of the unique things they bring, corporates and the private sector brings is not just here are our technical folks and we can work on this and bring technical resources to the R&D programs, but also making sure that they can help be the commercial and business filter to say, is this technology really, if it does pan out, is it transformational enough that it really matters, or is it on a 10-year development horizon of this one particular piece of technology, it's not all that meaningful in the long run. That's an important kind of filter to have. So it's not just bringing in the technical folks from the private sector, but also making sure there's a proper business filter there. The other thing I'll say is I think in our experience, we were able to use our sort of model to do a lot of the kind of early stage R&D on this technology. And then we were able to work with, find the right corporate partners to support that kind of mid-stage pilot demonstration plant. But where there's still a critical role that shouldn't be forgotten is in sort of the commercial deployment stage of the technology. There is a very important, very big, very real need for public sector involvement in sort of serial number one of any technology. Anyone who's gone through this understands that there are just costs and risks that no matter how promising a technology is, no matter how competitive number two will be, number one has to get over certain hurdles. These aren't even, we're not even talking, well, as you move down sort of manufacturing curves and other sort of efficiencies, you'll get down the cost curve. We're talking about just built-in contingencies and costs layered on that disappear or dramatically reduced for number two, but for number one, you've got to get over that hurdle. So I think we should make sure we don't lose sight of the importance of the government's role in working with the private sector to deploy even a first commercial.
Thank you. That's a really good point. I think I can kind of combine the last two questions. The general idea here is if these kinds of innovative breakthrough technologies are successful, like the Allen Cycle project, what does that mean, for example, for the U.S. export market? What does it mean for CO2 utilization markets? Would you mind talking a little bit about what this could mean if the technology works exactly as planned?
Well, first of all, at a cost level, and going back to my days when I used to work in the markets, energy acts as a tax on the economy. And the higher the cost of energy, the slower the economy goes. It's almost like interest rates. And we're facing a world, certainly in the developing world and the developed world, where the developed world could very well afford higher energy prices, but it would still come as a drag to their economies. The developing world, on the other hand, cannot afford higher energy prices. And at some point, we have to understand that just as there were externalities of carbon emissions, and we worried about those a decade ago, we should also worry about the externalities of how we address carbon emissions, the cost of addressing carbon emissions. And by making unwise choices, we will slow down world growth and slow down the developing world. And that is why we have to focus on the cost as well as the benefits. And by doing so, we allow the world to grow in a vibrant way. And that is why for the Allen cycle, our focus is on letting the world meet every climate target and more without having to pay more for electricity. As that happens, we will also, we assume that CO2 currently is only available economically for enhanced oil recovery. And But yet we see that post-combustion carbon capture, which thought that with $100 oil was viable, it's no longer viable with oil at the current prices. And therefore, you have to make CO2, the marginal cost of CO2 has to be zero, the way it is for us. We cannot help but capture CO2. We don't add on any more equipment to capture CO2. We don't have any greater parasitic load to capture the CO2. We make CO2 zero marginal cost. When CO2 has zero marginal cost, not only is it available for enhanced oil recovery, it's available for building products. It's available for something something such as enhanced coal bed methane recovery, where you absolutely must have cheap CO2. It's available for industrial productions. It makes CO2 available for solar fuels. It makes CO2 available at a price point that's available for all sorts of things that we haven't seen up until this point.
Thank you. And I think we just have time for everyone to share maybe one thought that you'd like our audience to take away from today's discussion about corporate partnerships to finance carbon capture. And maybe, David, we can start with you, and then Walker and Bill, if you have anything to add.
Yeah, I'm sorry, Fatima, you cut out there for a second.
Okay, sure. Yeah, I just wanted to ask if there's anything in particular you'd like our audience to take away from today's discussion.
Oh, look, I think net power is a very promising technology. If we can realize the goals and objectives that the group has set out, we're going to be far better off than we will otherwise. To Walker's point, I think any startup probably needs a little bit of assistance from the federal government just to prove out the commercial scale operation of the facility, and hopefully we won't be short-sighted in what we're doing here. There are a lot of incentives in here or in the federal policy playbook for emissions-free generation. There's nothing that would apply directly to net power in terms of gas-fired generation that would be carbon neutral here. So, if we can get something going there, hopefully we'll be able to accelerate the commercialization of these plants. And again, to Bill's point, I think it really opens up amazing doors, not only domestically but overseas, for the spread of this clean technology.
Great. Walker, I don't know if you have anything you want to share with the audience?
Yeah, sure. I'll just briefly say this is focused more towards the folks out there on the technology development side, but don't just view customers as customers, but figure out how to view them as partners that can help you deploy the technology, that can help you develop, finance, and deploy it. And I think they'll be able to bring kind of enormous benefits to you to help you execute.
Yeah, and finally, in closing, I would just simply say we at Net Power are very committed to this world. And if you have technologies that could work with our technology, if we can help you, we love to develop new technologies and develop this space. So please come to us for this. I mean, as I said earlier, we will have test facilities available for you. We have more expertise in this than a lot of other people out there. We would love to work with you in helping you get your technology to where it needs to be.
Great. All right, let's wrap up our presentation today. I'd like to thank our speakers for sharing their insights. This is a really important topic and a really exciting project. Again, we'll post the slides on our website, and watch for upcoming webinars on this and other topics at C2ES, including a series on green bonds coming up in 2017. Thanks for joining with us and sticking with us through the end. Have a great afternoon. Thank you.